Welcome to Spelling Bee Ninja's educational podcast, where we explore exciting concepts in science and beyond. Join our community of curious minds as we dive into the fascinating world of physics. Today, we'll be unlocking the secrets of key physics formulas that govern motion, force, energy, and electricity. So, if you're ready to enhance your understanding and ignite your passion for science, subscribe for free and let's get started together. Let's begin our journey into the fascinating realm of physics by exploring Newton's second law of motion. This fundamental principle states that the net force acting on an object is equal to the product of its mass and acceleration, expressed as F equals ma. Here, force is measured in newtons, mass in kilograms, and acceleration in meters per second squared. Imagine a scenario where a car weighing 1,000 kilograms accelerates at 2 meters per second squared. To find the net force required, we can simply insert the values into the formula. So, we multiply 1,000 by 2, which gives us 2,000 newtons. This illustrates how force directly corresponds to both mass and how quickly an object is moving. Physics is all about understanding these forces and their effects on motion. Next, we'll discuss weight, which is defined as the force of gravity acting on an object. The formula for weight is W equals mg, where m is the mass and g is the acceleration due to gravity, usually taken as 9.8 meters per second squared on Earth. If we consider an object weighing 10 kilograms, we can find its weight by multiplying 10 by 9.8, resulting in 98 newtons. Understanding weight is crucial, especially when studying how different objects interact with gravitational forces. Now, let's turn our attention to kinetic energy, which is defined as the energy of motion. The formula is Ke equals 1/2 mv squared, where m represents mass and v symbolizes velocity. This energy is measured in joules. For instance, if we have a 2 kilogram object moving at 3 meters per second, we can determine its kinetic energy by substituting the values in. First, we square 3 to get 9, then multiply by 2 to get 18, and finally divide by 2, which gives us a total kinetic energy of 9 joules. This concept highlights how an object's speed and mass can significantly influence the energy it possesses. Let's now explore gravitational potential energy, which is the stored energy resulting from an object's height above the ground. The formula for this is Pe equals mgh, where m is mass, g is gravity, and h is height. If we consider a 5 kilogram object lifted 2 meters into the air, we would multiply 5 by 9.8, and then by 2. This catches our potential energy at 98 joules, demonstrating how height plays a vital role in energy storage. Moving on, let's discuss the concept of work, defined as the energy transferred when a force causes displacement. The formula we use for work is W equals Fd, where F equals force and D equals distance. If a force of 50 newtons pushes a box 3 meters, we calculate the work done by multiplying 50 by 3, giving us 150 joules. This connection between force, distance, and work is fundamental in various physical activities and machinery operations. Next, we delve into power, which refers to the rate at which work is done or energy is transferred. The formulas for power include P equals W over T, or P equals delta E over T, with the units measured in watts. If a motor completes 1,000 joules of work in 5 seconds, we find its power output by dividing 1,000 by 5, resulting in 200 watts. Understanding power is essential, particularly in contexts relating to energy consumption and efficiency of devices. Now, let's take a closer look at electricity with Ohm's law, which states that the voltage across a resistor is equal to the current multiplied by the resistance. This relationship is expressed as V equals IR, with voltage measured in volts, current in amperes, and resistance in ohms. In a circuit with a resistance of 10 ohms and a current of 2 amperes, we can find voltage by multiplying 10 by 2, equaling 20 volts. This fundamental principle aids in understanding electrical circuits and their behaviors. Continuing with electricity, we explore the concept of electric power, which is the rate at which electrical energy is transferred. The formula we use here is P equals 4, meaning power equals current multiplied by voltage. Another expression is P equals I squared R, or P equals V squared over R. If we have a device drawing 2 amperes of current at 120 volts, we multiply 2 by 120 to find a total power of 240 watts. Understanding electric power helps us appreciate how electrical systems operate and the importance of efficient energy use. Next, we engage with the concept of density, which describes the mass per unit volume of an object. The formula is ρ equals m over v. For instance, if an object weighs 50 grams and occupies a volume of 10 cubic centimeters, we can find its density by dividing 50 by 10, yielding a density of 5 grams per cubic centimeter. This measure is essential in fields like materials science and engineering, as it influences how substances interact in various environments. And lastly, we touch upon Einstein's famous mass-energy equivalence formula, E equals mc squared. This equation illustrates that mass can be converted into energy, a principle fundamental to nuclear power and our understanding of the universe. If 1 kilogram of mass were converted entirely into energy, we would calculate the energy using the speed of light squared. This results in approximately 9 times 10 to the power of 16 joules of energy, highlighting the vast amounts of energy stored within even the smallest masses. This equation not only revolutionized physics but also provides insight into phenomena like how stars produce energy through nuclear fusion. As we summarize this wealth of knowledge, we see how each equation serves as a building block in understanding the workings of our physical world. Each formula connects to real-world applications around us, from the fundamentals of motion to the intricate workings of electricity. Equations form the backbone of scientific inquiry, offering insights that pave the way for technological advancements and a better understanding of nature's laws. In this lesson, we covered key physics formulas that govern motion, force, energy, and electricity. We discussed Newton's second law of motion, the concepts of weight, kinetic and potential energy, work and power, along with the principles of electricity as defined by Ohm's law. Each formula provided us insights into how objects interact in our physical environment. We also learned about density and Einstein's mass-energy equivalence, opening a window into the universe's fundamental properties. Understanding these principles not only enhances our knowledge but also equips us for further exploration in the field of physics. Thank you for joining us today on Spelling Bee Ninja's educational podcast. We hope you found this exploration of physics equations insightful and engaging. Remember, these concepts impact the world around us, enhancing your understanding of science and its applications. Don't forget to subscribe to our podcast for more enriching lessons and tools to support your learning journey. Until next time, stay curious and keep exploring the wonders of science.